Hey everybody, how's it going? I hope you're having a lovely day. Today I would like to follow up on a video I did titled The Downfall of Amazon, Dangerous Products, Fake Reviews, and Vanishing Brands. In this video, I decided to compare an electrical crimp that I had purchased on Amazon from one that I had purchased from Home Depot. The electrical crimp that I purchased from Home Depot could be tugged on numerous times, and it doesn't come off because Gardner Bender makes good crimps, and Home Depot tries their best to not sell things that will light your house on fire. Whereas the Amazon crimp that I purchased would come out if I tugged on it the tiniest bit, because it's a low quality piece of garbage. As I talked about in a video I did 10 years ago, many brands are deciding that they do not want to sell on Amazon because of the way that they're treated. And as a result of many good brands exiting Amazon, the unfortunate reality is the only people that are left are people that sell really substandard product that in many cases is not just bad, but is actually dangerous. And what's further dangerous is that Amazon's review system is so horrible that these products that are functionally dangerous and objectively don't do their job were 4.6 to 4.7 stars with 255-star reviews. As if you needed any more reason to believe that these reviews are fake, this really takes the cake in my opinion. So after doing this video, somebody who had a motorcycle channel reached out to me and said, Lewis, if you think that's bad, you should check out their fuses. So I decided to buy 3 sets of automotive fuses on Amazon. And what I'd like to do today is I'd like to use my setup that I have here at my shop to test them and see if these automotive fuses actually blow where they are rated to blow. So for those of you who don't watch my channel regularly or don't really get into the electronic side of it very much, the whole point of a fuse is to blow when a system is asked to deliver more power than it can. So just highly oversimplified explanation. I have a power supply that's made to do 100 watts, and something that I've hooked up to it asks for 500 watts. With a fuse that's rated for 100 watts, when that system that's supposed to ask for no more than 100 watts asks for 500 watts, the fuse is supposed to blow, breaking the connection between what I'm powering and my power supply so that my power supply is protected, doesn't try to deliver 500 watts that it cannot deliver, and doesn't go on fire. Whereas if I did not have a fuse there, or I had the incorrect fuse there, my 100-watt power supply, when that system fails, may actually try to deliver 500 watts that it is not capable of delivering. As a result of that, maybe it just fails gracefully, maybe the wires fray, maybe it goes on fire. There's a reason that fuses are important, and there's a very good reason that we should take it seriously when fuses are mislabeled or don't blow when they're supposed to blow, because it's actually kind of dangerous. Bad things can happen as a result of it. Yeah, there's protection circuitry and current sensing and everything else, and I'm not trying to get into the EE side of all this and everything else that is used in modern circuitry so that doesn't happen, but you get my point. You want fuses to actually blow when they're supposed to blow. So what I've done over here is I have created a setup to test this theory and see if this gentleman is actually correct. I have purchased 3 different sets of 32-volt fuses off of Amazon, and here's what I have. I have 3 bench power supplies that are attached in parallel. Each one is capable of delivering 5 amps, so since I have 3 in parallel, I'll be able to deliver upwards of 15 amps with the setup. These fuses are 32-volt fuses, so I've set the voltage on my power supplies over here to 32 volts, and in case you're not able to read that, I will just put my power supplies measurement from my multimeter on the screen so that you can see that I've got, when I turn this thing on, 32.01 volts, close enough. That is 32 volts. And what I have down here is a loop that I'd like to show you that I'm going to be using for testing this setup. So the ground of my power supply is going to a bus bar. The bus bar has 4 of these little alligator clips sticking off of it that are going to go to these 16 ohm resistors over here that I'm using as a load. Then from these 16 ohm resistors, we have these red wires over here that are going to my other bus bar that is connected to a fuse holder that then goes to the positive of my power supply. So my loop is going to be completed through the fuse holder and through the resistors. This here is a 16 ohm, 100 watt resistor. There you go. And what I'm doing here is I'm using that to set the load. So if you go to an Ohm's law calculator over here, again, you don't have to get into all this if you're not into electronics. If I have a 16 ohm resistor, that should limit the current to 2 amps, which is the size of the lowest fuse in this pack. So what I'm going to do is I'm going to hook up a 2 amp fuse to my fuse holder, and then I'm going to continue to hook up resistors, because the more resistors I add in parallel, the more power I'll be sending through my circuit, and I want to see at what point does this 2 amp fuse actually blow. It is a 32 volt fuse, it is rated for 2 amps, does it actually blow at 2 amps? Does it blow at 4, 6, 8, 10? Who knows? It's Amazon. So let's have some fun. I actually haven't figured this out myself, and this one over here is Yeah, let's take a look and see what we got. So first set that's up is this thing over here. This is a 272-piece blade fuse set. Let's open this up. So according to this color code we got here, it looks like the one that I'm looking for is going to be this dark gray. So we have kind of like a light gray or a white. I'm partially colorblind, so excuse me for messing this up a little bit. And I think that that's like white or light gray, and that looks like dark gray over there. So we are going to grab the dark gray fuse and see how that goes. So let's grab one of these and see if you blow and where you blow. Okay, so we got this. I'm going to take this and I'm going to put it into my fuse holder over here. All right. Let's get a nice connection going there. Okay, nice and pushed in the fuse holder. Next up, I am going to turn on the bottom power supply. I don't need all three of them because this power supply is capable of 5 amps and we're only starting off with 2 amps. So I only have one resistor hooked up here. So we are only going to have one resistor, which means we should be getting no more than 2 amps of output. So let's have some fun. So when we turn it on, you can see that we have 2 amps of output at 32 volts, and that is all. Now I'm going to hook up another one of the resistors in parallel. Since I'm hooking up a resistor of the exact same resistance, which is 16 ohms, in parallel, I'm effectively halving the resistance, which means I should get twice the power. Let's go for it. As you can see, I've hooked up another resistor in parallel, and we now have 4 amps of output. Now, I'm going to reach the limits of the power supply in a moment, so I'm going to turn on a second power supply in parallel, and they're going to share the load there. As you can see, each of them is outputting approximately 2 amps now because they're working in parallel, and I'm going to attach another resistor. Let's attach another resistor in parallel, effectively halving the resistance yet again. I have attached another one, and as you can see, now there's about 6 amps going through here. You have 3.4 at the top, 2.5 to 2.6 over here. So I am currently putting 6 amps through a 2 amp Amazon fuse at the maximum voltage it is rated for, which is 32 volts. I'm actually going to be fair over here. Before I hook up more, I'm going to assume that this is a slow blowing fuse. So I'm going to go over there to the bathroom and take a piss and come back and see if this thing is still boiling and burning before I add any more to it. I'm actually going to give it some time to blow. We're going to be fair here. Okay, so I've used the restroom, I went upstairs to take a phone call, and I got myself a bottle of water, and after all of that, as you can see, it looks like we are still putting 6 amps through a 2 amp fuse, and also these resistors are really starting to smell like crap, so I hope you'll excuse me if I put my fume extractor on at some point. What I'm going to do now is I'm going to turn on the third power supply over here, and we're going to see if I can deliver more. So I'm going to attach another resistor in parallel over here, and I may actually have to make some more cables because I was not planning for a 2 amp fuse to last this long. As you can see, I've attached another resistor in parallel, so now I am outputting 3, 4, 6, I'm outputting 8 amps through a 2 amp fuse, and it's still going. Now the thing is, these power supplies have the ability to continue delivering current. So I have more resistors over here. Let's try some more. If you'll excuse me, I actually have to make some more wires. I was not planning to have to put more than 8 amps through a 2 amp fuse, but I should know better because this is Amazon. So I'm going to make a couple more of those wires, and I will be right back. Okay, we're back. So I've actually added a bunch more wires to the setup, and I also put this over here because apparently I was burning my desk. So now instead of having 4 wires and 4 resistors, I have 7 resistors. The reason that I only bought bus bars that had space for 4 over here, 1, 2, 3, 4, is because I actually did not believe that I would be putting more than 8 amps through a 2 amp fuse. That never entered my mind. But apparently that's a thing. So, oh, dear God, why'd I touch that? So I'm going to do is I'm just going to disconnect all of these on the left side. I'm going to attach all these on the right side. And then we are going to get back to our regularly scheduled programming of how many amps can I put through a 2 amp Amazon fuse. And if you would like to repeat this experiment, I will leave links in the description down below for anybody that wants to see just how little Amazon gives a crap about your safety, or pretty much anything, honestly, other than making as much money as humanly possible off of your misery when you purchase products that are highly reviewed and, in my opinion, a complete scam. Let's continue. All right, let's get this over on the desk. A little bit neater. It bothers me if I see them touching, even though I know it's not going to short anything. Okay. Also, if you'll excuse me, I have this fume extractor on because these resistors smell like garbage when they get hot. So I'm going to turn each power supply on, and I'm going to hook them up one by one. So we have this one. Okay. One. Okay, that's going to be 2 amps. 4 amps. Yeah. Do this. 6 amps. 8 amps. Take a look. 2, 3.6, 2.4. 8 amps through a 2 amp fuse. But wait, it gets better because I still have more resistors left. Okay, we're going to hook up the 5th resistor. The fuse finally blew. I need to put 10 amps through a 2 amp Amazon fuse in order for it to actually blow. It didn't blow until I put 5 times the rated current through it. All right, let's try a different brand. So just before we finish this fuse over here has 4.6 stars with 2,485 ratings. And if I search on Amazon for automotive fuse kit, nilight shows up, yeah, in the first 5 results. God only knows how many people have purchased this and installed it thinking that these are actually real fuses rather than misbranded garbage. Now, I know what I'm going to see in the comments because I've been doing YouTube long enough and I've been uploading videos on electronics repair and live streaming it for long enough to realize that there's going to be somebody in the peanut gallery that says, I demand to see the datasheet and the curves for that fuse that is rated at 2 amps. They don't always blow at 2 amps or even 3 amps. Sometimes it takes a little bit more because you have to have it heated for some amount of time. Let's put aside the fact that there's a greater chance that I will be able to get a board view and a schematic for the newest MacBook hand-delivered to my door by Tim Cook, USB drive with BRD files in one hand, heated up pecan pie and a warm welcome in the other, than there is of me getting a datasheet or a curve set for a Chinese fuse that I purchased on Amazon.com. In what scenario would you engineer a device that is spec'd for a 32 volt 2 amp fuse and be okay that that fuse get warmed up at 2 amps for a few minutes, warmed up at 4 amps for a little bit more, warmed up at 6 amps, 300% what it's rated to actually blow at for another 4 minutes, and then a little bit more at 8 amps, which is 4 times what it's rated to blow at, and then finally blow at 10. Like, there's, no. Just no. Like, just take that shit somewhere else. Because, like, no. Just no. Back to the video. Let's try the next kit over here. So this is going to be from a company called Kzper. We're going to try the Kzper fuses over here. This one I actually haven't opened yet. So we're going to, AVE it up a little bit over here. This packaging die. And I'll start back at 2 amps to be fair. This one over here actually has 5 amp, 10 amp, 5 amp, 7.5 amp, 10 amp, and 15 amp. So I'm going to do a 5 amp and see how much I can put through. So this over here, just move the camera over and do a little bit more zoom. All right. So let's see how these are color coded and labeled and all that stuff. So the 5 amp fuse is the smallest one, and the 5 amp is the orange one, which is going to be this. So let's see. Does this blow at 5 amps, or is this going to require that I put 15 amps through it? One way to find out, right? So I'm going to take the old fuse out. I'm not going to use a fuse extractor. I'm going to trigger you all by using flush cutters to take that fuse out because I'm an animal, and also it's a dead fuse, so why do I give a shit? Absolute animal. I pulled the freak. And we have our orange fuse. Orange fuse. Eh? No magician shit. Wish I had the talent to be a magician. Okay, that is the orange one. I'm gonna push you in. Make sure it's nice in there. Okay, I'm going to disconnect all the grounds and we are going to attach them one by one and see how long it takes to kill this. Also, those resistors not only smell horrible, but they're also hot. So, this. Okay. Beautiful little setup over here. Lovely. Absolutely artistic in nature. Okay. So, I'm going to turn on all the power supplies. Actually, I'll just turn on one. I'll turn on all the power supplies here. What the hell? Turn them all on. Okay. We're going to start with one down here. Okay, we should have no problem there because remember, this is a 32 volt fuse and it's rated for 5 amps. So 5 amps, I should be able to connect at least 2 of these, no problem, which I did. Okay, so that is 4 amps. Let's try 6. 6 is fairly close to 5, so that's okay, it didn't blow. Let's try 8. 2, 4, I'm gonna do 8. Okay. So we have 1.8 plus 3.6 plus 2.5. Close to 8. Let's try 10. You got 10? Okay, it blew at 10. It's better than the other one. The other one allowed me to put 4 times as much in, whereas this one only allowed me to put almost twice as much in. So this brand, okay, Kzper, a little bit better. A little bit better. I had to put 10 amps through a 5 amp fuse to blow it, but that is better than before. Let's try the next one. So the next one over here, and let's just unplug everything first before I move on. Yoink. Oh, I gotta see what the Kzper reviews are, by the way. Very curious. Okay, here we got Kzper. Oh, look at this. 4.7 stars with 3,955 reviews. But again, keep in mind, this fuse over here is better rated with more ratings because I only had to put twice the power it's rated for into it rather than 5 times the power it's rated for into it before it actually blew up. Let's try another one over here. So this is going to be the, what do we have at the bottom? This is going to be the CrocSee. Here we go. Let's try a CrocSee. So this is CrocSee. And this one starts off at 2 amps. Beautiful. It looks like 2 amps are gray. Just make sure I actually pick out a gray one instead of picking out the clear or the white one. And let's see what we got here. Okay, we got a fuse. Put it in here. I'm going to grab out the old one. Use my needle nose pliers for this. I'm weak. I'm a sissy man, so it actually hurts. Takes a little bit of time to do that. And I actually lost the fuse I put on the desk, so I'm going to grab another one. Okay, this is gray. Gray is 2 amps. I'll zoom in so you can see. It's about as much zoom as I get. All the power supplies are off and unplugged. And we're going to do the same thing again. Push that in as far as it goes into my beautiful little fuse holder. We're going to turn on all of my power supplies. 2, 3. And we're going to connect these resistors one by one. So this is a 2 amp fuse, and we're going to start by putting 2 amps into it. 0.9 plus 1 plus 0.1 over there. Looks like it's balancing itself pretty much to 2 amps. So we got 2 amps, 2 amp fuse. Let's see if I can do 4. Okay, I will hand it to the CrocSee. The CrocSee actually blew at 2 amps. I was about to add more power to it, but right as I went to pick up one of these to add more power, as you can see over here, it blew and it's no longer taking any power. Now, just out of curiosity, to see if that was a fluke or not, I'm just curious. Let's see what happens if I grab another one. If another one does the same thing, this might actually be a brand that is remotely trustworthy that is selling on Amazon. And as you can see, this one is actually much better rated, 4.7 stars with 10,000 reviews. So this one is actually might just be something that you should trust. One way to find out. Plug it in again. And we're going to turn on my power supplies again and see what happens. So this is putting 2 amps in. Remember, 1 16 ohm resistor. Let's see what happens if I connect another one. The moment that I connected 4 amps, it immediately blew. This is a quality fuse. So I had the wrong fuse, so I'm actually going to do that again, since I don't want you to miss it, because this CrocSee actually did something decent. So I'll get one more. I feel like this company earned and deserved to be shown as the only one here of the 3 that I purchased that is not selling fraudulent fuses. So I just put that in there. That's another gray CrocSee fuse. And all my power supplies are on. So I'm going to add this. I'm going to wait 10 seconds. 2 amp fuse. 10. Okay. We're going to add 4 amps now. So it's carrying 2 amps and it's working. The moment I add 4 amps, you saw the little spark and the flash, and it died. If you're watching this video and you're a regulator, do me a favor. Don't trust me. Don't trust me. I would suggest that you go over to your local college's electrical engineering department and ask anybody there to set up this very basic experiment that I set up. They'll be able to do it inside of 10 minutes after they buy the proper tools, and they'll be able to demonstrate the exact same results that I've demonstrated here. I don't want you to trust the results of some random internet YouTuber. I want you to see it for yourself. We're not talking about knockoff Cheetos where they don't last as long or have as good a flavor when the bag has been open for a day or two because they use cheaper preservatives. We're talking about products that are actually relied on for safety of electrical systems, and we have some sort of basic trust in this country that, you know, okay, fine, I may not get the best service when I go to this restaurant, you may not be able to do the best job painting my living room, but at the end of the day, we trust that when we buy a fuse, what we're buying is actually what it's rated for. The idea that I could buy a 2 amp fuse that does not blow until I put 10 amps through it, That's messed up. That doesn't work in a high-trust society. A high-trust society is incredibly important because if I have to test every single component, if I have to go to a chemical lab every time I buy food, if I have to measure every single wire and open up every single thing that I purchase to make sure it is not going to hurt me or my family, I'm going to be much less productive as a result of it. My ability to go to Home Depot and purchase a fuse and just know that what I'm purchasing is actually going to blow at the rated amperage is part of what makes contractors, electricians, and everybody else productive and able to actually do their jobs. You may think it's silly. Yeah, of course, a pro electrician is not buying their automotive fuse off of Amazon. And you're right, they're not. The problem is there are many people that are going to go to Amazon and see 4.6 stars, 2,400 reviews, and think, oh, Amazon wouldn't screw me with a product that I rely on to keep me safe and to keep my electrical system safe. There's no way they would do that. Many of these reviews are likely fake reviews. In my opinion, a lot of those reviews are fake. But unfortunately, many of these reviews may sadly be real from people that saw the good reviews and bought the product and simply plugged it in without doing the testing. Your average person buying this product does not have all the test equipment that I have here to be able to figure out whether or not what they bought actually matches the label on the package. They're just going to plug that thing in and see that their system works again and be happy, not realizing that the next time that system goes wrong and something breaks in it, that 2 amp fuse is not going to blow at 2 amps. It's not going to blow at 4 or 6 or 8. It's going to take 5 times the power it's rated for to blow, and that's going to be really unfortunate if that actually winds up hurting somebody. The worst part of all of this is that Amazon kicked every independent seller off of their platform of Apple products 5 years ago. And as I go over in this interview that I did with John Bumstead, they claim the reason for this is because they want to make sure they have a safe marketplace where their customers are being treated properly. You can't trust these independents like Lewis to sell a refurbished MacBook and actually satisfy customers, can you? That could be unsafe. But at the same time, they're more than happy to keep these products in their marketplace. A 2 amp fuse that doesn't blow until I put 10 amps through it. Which do you think is less safe for the consumer? At the end of the day, the worst part of all of this is there is zero policing going on of anything in this actual marketplace, because the very crimp that I went over in this video that I said was bad is still being sold in that website today. This is unfortunately not a self-regulating marketplace, and if people are going to be kept safe, somebody needs to step in and say, hey man, you can't sell products that functionally don't do what they say they're going to do in a product category like electronics and safety. Amazon is not going to stop, nor is it ever going to try to quality control or regulate any aspect of its online marketplace. And the unfortunate reality is, since they won't, a regulator, in my opinion, should. If you take a look at the product that I went over, those crimps that did not function from the video that I did 2 weeks ago, you'll see that you could still purchase those crimps on Amazon.com today. Not only can you still buy them, but the 1-star review that I posted for this crimp that didn't actually work never even showed up. You won't find my review at all. Not only is Amazon selling mislabeled electrical products that are unsafe, they're also of those products when users like me leave them, and they keep them up on their marketplace anyway. I've contacted several people that I know that are Amazon employees, and I've also reported the product on the product page. And I also have a video on YouTube with over 700,000 views demonstrating that this is an unsafe product, and in spite of all of this, that product stays up. If I can't get Amazon to realize that selling defective electrical products is dangerous and bad for people's safety, and maybe that should be pulled from their marketplace, what chance do you think normal, average, everyday users that don't have 2 million subscribers on YouTube have of getting them to actually take accountability or responsibility for peddling this garbage? Amazon is not going to stop selling people garbage that is, in my opinion, unsafe, broken, and falsely advertised and maliciously labeled unless somebody holds them accountable. And right now, they're continuing to grow in their valuation, they're growing in their income, and there's no reason to stop what they're doing because what they're doing is working. What I'm asking you to do, both customers and regulators, is hold Amazon to task. Hold them accountable. Hold them to the very same standard at the very least that you would hold me to in my business if I sold you a 2 amp fuse that didn't blow until you put 10 amps through it, or an electrical crimp that didn't actually work. Even in a state with more lax business laws like Texas, if I were selling products like this, I'd be shut down within a week. Yet a multi-trillion-dollar company that is known around the world can continue to sell these products with impunity. They can continue to hide the negative reviews that are posted about that product when people post them, and the products stay on the website even after I do a clear demonstration of how they not only not work, but are unsafe. And mark my words, if you want to look back at this fuse kit that I purchased from Nilight, I guarantee you, I would bet my business that 1 week from now, after I report this product to Amazon, after this video has almost 1 million views, that product will still be for sale. a 2 amp fuse that is mislabeled that doesn't blow until you put 10 amps through it because they don't care. And they're not going to care until regulators or customers or both give them a reason to care. And the way you give them that reason to care is as customers, you stop giving them money. And as regulators, you hold them accountable to the same standards that you would hold me accountable or anybody else in my industry if we sold these types of mislabeled, defective, and dangerous products. That's it for today. And as always, I hope you learned something. I'll see you all in the next video. Bye now. And for fuck's sake, if you are buying fuses, do not buy them on Amazon.